The binomial theorem gives a general formula for expanding a binomial. Take note, theorem, binomial theorem. For every positive integer n, a plus b to the nth power equals p sub 0 times a to the nth power plus p sub 1 times a to the n minus 1 power times b plus p sub 2 times a to the n minus 2 power times b squared plus, and that pattern continues, plus p sub n minus 1 times a times b to the n minus 1 power plus p sub n b to the nth power, where p sub 0, p sub 1, and so on, all the way through p sub n, are the numbers of the nth row of Pascal's triangle. When you use the binomial theorem to expand this binomial, x minus 2 to the 4th power, a equals x, the first term in the binomial, and b equals negative 2, the second term in the binomial, to expand a binomial such as 3x minus 2 to the 5th power, a equals 3x, and b would equal negative 2. Remember that a to the 4th, in this case, will equal 3x in parentheses to the 4th, not 3x to the 4th. In the second case, the 4th power is only applied to the x, not also to the 3. Problem 2. Expanding a binomial. What is the expansion of 3x minus 2 to the 5th power? Use the binomial theorem. Consider what you may think on the left and what you may write on the right as you work through this problem. First think, for the binomial 3x minus 2 raised to the 5th power, use the 5th row of Pascal's triangle. And then write or consider the 5th row of Pascal's triangle. 1, 5, 10, 10, 5, 1. Then think, the binomial theorem uses a binomial sum. And write 3x minus 2 to the 5th power equals 3x plus negative 2 to the 5th power. This makes it easier for us to identify the first and second term that we'll use with the binomial theorem. Then think, apply the binomial theorem, and apply the binomial theorem as you write that the expression equals 3x to the 5th plus 5 times 3x to the 4th times negative 2 to the 1st power plus 10 times 3x to the 3rd times negative 2 squared plus 10 times 3x squared times negative 2 to the 3rd power plus 5 times 3x to the 1st power times negative 2 to the 4th power plus 1 times negative 2 to the 5th power. Finally think, simplify, and simplify. Write the simplest form, standard form, as 243x to the 5th power minus 810 x to the 4th power plus 1080 x cubed minus 720 x squared plus 240x minus 32. Your turn, part A. What is the expansion of the binomial 2x minus 3 to the 4th power? Use the binomial theorem. And part B, a reasoning item. Consider the following. 11 to the 0 power equals 1. 11 to the 1st power is 11. 11 squared equals 121. 11 cubed, 1,331. And 11 to the 4th power, 14,641. Why do these powers of 11 have digits that mirror Pascal's triangle?